Good morning, dear students. Today we are going to talk about columns. Column is one of the main structure in the building because all or maybe most of all loads is accepted by the columns in the frame building and only then transmits to the uh, foundations and then to the soil. So today we'll discuss about types of the columns and their application, their forms, materials, and so on. A column or pillar in architecture and structural engineering is a structural element then transmit through the compression the weight of the structure above the other structural elements below. In other words, a column is compression member. So the term column applies especially to a large round support and with a capital or base pedestal, which is made in ancient time. It was made of stone, and nowadays it's made from the concrete, monolithic concrete, prefabricated concrete, or sometimes from the steel. So, but a small wooden or metal support, typically call it a post, and support with the rectangular or other non-round section are usually called a piers. So a piers, like a construction, most of all is applied in the bridge construction. So for the purpose of dynamic loads like wind and earthquake engineering, columns may be designed to resist the lateral forces. So other compression members are often termed like columns because of the similar stress conditions. Columns are frequently used to support beams, arches, trusses, which the upper parts of walls or ceiling rests. So in architecture and in civil engineering, columns refers to such a structural element that also has some certain proportional and decorative features. So column might be also not like a structural element, but also like a decorative element. So and not actually when it not needs the structural purposes. So many columns are engaged. That is to say a part of a wall. So along sequences of columns joined by entablature, as known as colonnade. So there are several types of columns which are used in different parts of the structure. So column is, as I told you, is a vertical structure. At least the lateral dimensions exceed to 20 and call it as a long structure. So a long column fails by bending or buckling. So a short column is one of those ratio of effect lengths at least less lateral dimension is less than less or equal than to 20. So it's that's why it's call it like short column. Intermediate columns. So intermediate columns, it is steel column or reinforced concrete columns with a slenderness ratio of 40, less or equal to 120, as defined as intermediate column. So the mode of failure is combination of crushing, yielding, and buckling column. So and the actually column classification based especially on the slenderness. So, what about main differences between short columns and long columns? So, actually, the first and in some cases the main difference is in place of application. So, the most people confuse when asked the difference between long column and short column. So people interchange the meaning of these two terms. So these two terms share some similarities actually, but they are different from each other. So the column is most essential part of any structure. So there are different types of columns are used in structure. And on the next screens slides will see it, how many types of columns are there are in the construction site. So according to slenderness ratio, columns have only two types. It's short and long. And the variety of the columns is sliced into these two types. So let's try deeply understand what does it mean short column. So short columns, the ratio of the length or height to its lateral dimension is less than equal to 12. Is known as a short column. So in the same time, the long column ratio of length or height of the column to its lateral dimension is greater than 12. That's why it's known like long column. So short column can fail because of their crashing. So local column can fail because of their buckling. So, and in the same time, the short column do not fail by the buckling. So the radius of gyration of long column is less. So the short column are subjected to compressive stresses, but the long column ratio of the length radius of gyration is greater than 40. So what else about differences? So maybe the load carrying capacity of short column is much more due to its low height, but the load bearing capacity of the long column actually is less due to its more height. So the short column is stronger than long column, and in most of the building, the short column is more recommended or highly recommended. So the lateral dimensions of short column is small in comparison with its height. The long columns is weaker than short and usually not preferred to use it in the civil engineering, so in the civil buildings, public, and so on. Just only in that case when there cannot be found any solutions, like just to apply the long columns. For example, there should be height level of the floor inside the building, and we need to create more open space, more open place. In that cases, of course, um, solution of applying the long columns is one of the best solution. Okay, let's start discussing about types of the columns. And firstly, we need to classify, make the right classification, yes, based on several conditions, which are include the um, types of reinforcement, types of loading, slenderness ratio, shape, and construction material. So, tied column or RCC column, reinforcement concrete columns. The type of column uh, commonly um, used in construction, and it made from the reinforced concrete. So longitudinal reinforcement are confined within closer spaced tire reinforcement. It's estimate then about 95% of all columns in building are tied. So on the picture you see examples of tying. So there are vertical reinforcement and uh, lateral reinforcement. So lateral reinforcement, call it like a lateral tie because it's tied four or sometimes more than four vertical armature, so reinforcement together, and create the durability into the slenderness of building and protect it from the crashing, from the buckling. And the shape of reinforcement concrete construction can be squared, rectangular, and circular. So most popular types. Actually, it can be various shapes. So according to the architectural and designer solutions. But in the same time, most popular is Z3 type. Vertical reinforcement is also called like a main vertical bars. So, and the distance between lateral tie is called spacing. In the construction site, the spacing, so dimension is equal to 100 millimeters. Sometimes it can be applied 150 or 100. So in the places with the higher strength, with in places where there are large loads are acted, and so on. Next one. So the tied column, if we'll compare with the spirital tower, there are will be or can be found some distinguishes between them. So, for example, a tied collar have a horizontal reinforcement. So, close ties or hoops. So this is different than in spirital column. So that will have reinforcement in form of continuous spirital that circles up and down the column. So note that the definition has nothing to do with whether the column is square or circular, and in fact, um, we can have a tired column or spiritual square column according to our choice during the design of the same structures. So, um, and the several specifications according to the spiritual column. So, spiritual column including the ratio of longitudinal steel area to the gross column, and must be between 0.1 to 0.08. So actually, respectively. So the clear distance between the spirals must between 1 to 3 inches. Um, the longitudinal bars have the space between the bars at least 1.5 times the bar diameter, so should be greater that at least 1.5. So 6 longitudinal bars is required to be used in the spiritual columns. Actually, at least 6 bars. So there can be applied more than 6, but at least there should be applied the 6 bars. Okay, next. Next one is the composite column. So composite column nowadays, um, we can get to see a lot of structures, big, small, modern, and old. What just a modern skyscrapers. So, and these structures are made out of extraordinary attainments in science and engineering nowadays. So the main focus has been shifted to the constructing the safe building keeping and the mind of economic aspects in project. So as far as residential and commercial purposes is considered generally in high-rise buildings, tall structures, towers, blocks are constructed. So uh, they may also be known like a vertical city, consists of ability to give more ground space, accommodating more people in the less space, hence giving the benefits such as beautiful skyline, important landmarks, and optimum land use. So main reason behind this have achieved structure stability, strength, and the stiffness. For which that purpose a new innovation came to the design to this introduction. So composite construction governs the non-residential high-rise story building sector. So this has been the case for over 20 years. So it's recognition is due to has a strength and the stiffness that can achieved with the minimum use of material. The reason why composite construction is frequently so good can be expressed on a simple way of the concrete is good in compression and the steel is good in tension. So combining of these two materials together, like you see on the pictures, so Structurally, the strengths can be exploited to result in a highly efficiency, a lightweight design. So composite, by other words, composite systems also offer benefits in terms of time-saving construction. The floor depth increases that can be achieved using composite construction, and also provides the major benefits in terms of the cost of services. So, in general, or in one word, the composite construction nowadays is a really popular type of construction. Actually, for high-rise buildings, for many-story buildings, for buildings located in the um, difficult constructional conditions and so on. And it really works. And if you will make some research work in the construction side of erecting many-story buildings, you can find the information that really this type of constructions are often used. Next one. So, structural concrete members may be subjected to axial load. So, fracture, shear, or torsion, or combination of these loads, so may be pre-stressed or not pre-stressed. So the principle of underlying the analysis and design are basically the same. So interior columns of multi-story buildings with the symmetrical loads from floor slabs, all sides is example of this type of column. So axial loading of columns means the loading acting on the longitude axis of a column. So eccentricity will not produce so moment, uh, will not so moment when the load is not acting on longitudinal axis of column. Eccentricity will produce some moment in the building. So an axial bending means bending in acting only on one axis, and biaxial bending. So moment acting on two axes of the column. On edge of column, building biaxial bending occurs, and the corner columns of building um, biaxial bending is acting on the column. So all what I told about, you can see on two pictures, and how the um, load is applied in what part of the column, on the section of the column it's applied. So you see that is applied in the central part. Next one. So when the vertical loads do not coincide with the center of gravity of column cross section, but rather act eccentrically either on x or y axis of column cross section. So it then that why it's called an axial eccentric loading column. An axial eccentric loading column. So columns subjected to load acting loading along the longitudinal axis or centroid the column section. So eccentrically loaded column and axial loading, when the load which do not act on the longitudinal axis of the column. So if the eccentricity is with the respect to both of axes, so it will be, I told you, biaxial loading. Biaxial loading. Okay, so biaxial loading. When the loads acts in the both direction, in act on either axis y and axis x. So biaxial bending affects columns where a load is eccentric about both of axis plane. So placed upon of a portion of column which is not symmetric with the central axis, so thereby producing the bending. Next, short column. So short column. Um, the strength is governed by the strength of material and the geometry of cross section. So about 90% of columns braced against sides way, and a 40 unbraced column could be designed as short column. So in spite of higher strength material and improved methods of dimensioning members, most column includes um, the slender, call it like lamps, and consider it designed as a short column. So previously I told you about features of the short column and the main advantages of it. And also we discussed about disadvantages of the long column too. So, like you see in the picture, so crashing failure. So there are main problem of short column. It is crashing, and long column. So the main features of the long column was discussed in the previous slides. So I told you about the definitions. I told you about advantages uh, on the and the time of its application. So reasons of its application. Uh, that's why I will just repeat that a column, the so slender that it will fail under the longitudinal load by the bending rather than crashing. So the bending, the failure can be more often finding than crashing, and typically have the length of the column of 20 to 30 times the diameter. So the square column. So both rectangular and the square columns are generally used in the construction site. So appropriate the shape and appropriate the shape is determined using interaction charts. So square column are used when the moments on either direction, so equal or to compression loads is very high. So usually square columns are provided as interior support. So columns of square or rectangular cross section made with the same grade. Uh, with the same grade of materials keeping the same height to thickness ratio, but varying varying cross-sectional dimensions. So the dimensions of the square columns are, for example, 150 to 150, and the height is 1,500 millimeters. So and I so there can be found that square columns uh, poses a great strength than rectangular one. So and if you will look in the literature, in the notes, articles, uh, you will understand this effect. And but actually, um, I could hardly find if just I will look through the literature about the proper explanation of this effect. Actually, this effect just maybe need to be um, tested. This effect need to be developed maybe by scientists and by designers. The steel columns. So there are variety of the steel sections. Uh, the size of building, uh, the distance between the columns, the magnitude of the load, so must be uh, channeled to the earth foundation. So the method of construction, the cost, um, availability, available time, the numbers of floors, the main factors to decide what kind of material of section, what kind of material, um, for example, wood, concrete, or steel, can be right selected for the proper design. That's important. And each of the section has its own bearing capacity, and according to it, they can be applied for various types of the buildings and structures. So for large buildings such aircraft manufacturing, warehouses, indoor buildings, so a roof load is relatively light. Just a rainwater and the roof's weight, but the distance between the columns are far enough that most likely steel columns is only a choice. So a single larger steel column sometimes it's not even strong enough to bearing the column load. So the column must be fabricated using the several sections. For example, like you see on the screen. So that sections helps to building for with the large span buildings, with the high-rise buildings, B um, where is this shape? B with higher bearing capacity, with safety for people inside that building, with respect to the slenderness of the steel column and with the right designing of um, applying the right section, right steel, and applying the right numbers and step between the main columns, like in longitudinal section, so in the cross section. So, and some precautions of the column construction. It is process of construction, vertical height of concrete columns for more than one story, and the load on the top story. So all these precautions are take uh, into account during the design of the columns, during applying the materials, um, applying the way of design, the type of the column according to the centrical applied load on the axial applied load and so on. Okay, what I wanted to talk about today is just to give you information about main types of the columns, the main reasons why we need columns, um, the variety of the sections according to cross section, according to the material, and so on. So if you have some questions, maybe I have some time to answer all of it. Students? Okay, so if you have no questions, we'll continue our lesson on our practice. So practice will be next lesson. So um, let's see you on the next lessons. Thank you very much for the lesson.